Hi, I have again a nice repair for you. A Kenwood TS50 doing funny things. So I've been told that the radio is producing a funny tone, maybe a 1 kilohertz tone, simply when it gets switched on. And beside that, something is wrong with transmission power. So the radio does transmit, so no problem. But sometimes the radio is completely losing the transmitter signal, and it seems that basically something is wrong with transmit. So, let's check what we can find. Okay, so radio is connected to the power supply, and let's see what's happening when we switch it on. Oh yeah. So, can I adjust it? Ah, no, but the static is coming over it. And we are on SSB. So let's change, for instance, here our mode. Okay. So let's see what we get. Well, not so much. And it is what is going on here? Now it is blocking on CW. So no reaction on CW. And now it is responsive again. So let me... have a look. So radio is fully powering up here. So we have full output power without key and without anything. So let's go to upper sidebank, and power is dropping. So for me it looks like that what we hear is the side tone, and it could be that our jack is somewhat faulty. So it seems that we have a short in our key jack. So that seems to be a possibility. So okay, let's see. No, there is nothing. But of course, if we have a short, then we hear the side tone permanently. And let me see if I put a plug here into the key jack. So this is a normal 3.5 millimeter plug here. So let us put it in. Okay. So because nothing is connected here, and that means if the jack inside is making a short, and now our plug here is able to bring the contacts out, and then there is a short gone. So therefore it seems definitely, so it is gone, and static is still there, so no problem. So let's see if we go now back to CW, which is here, and no. So here is no power output any longer. No, so power meter does not report output power. Okay, so let me just double check it. I take out our plug here once again, and let me see if we switch now to CW. Yeah, you see this full power, and we can see it here on the meter as well. So full output power. Come on, focus. And that is a little bit high, 135. So that is a little bit high, so something is wrong with it as well. So let me put in the plug, and you see immediately our output power is gone, so indication is down, and that means that there is a short somewhere in the jack, so because otherwise we wouldn't be able to disconnect the tone. And it is like you press a key, right? So that is what has happened to the jack. So that's the reason why we hear the side tone, and we see, of course, the output power on CW. Okay, so then let's see what's going on here with power. I'm on AM, and the radio is set to, let me double check, to 100 watt output power. And now AM, and I hope you can read it here. So the dead key is 136, which is almost it is full power on AM, and dead key should be at let me say 25 watt. So yeah, that is definitely too high. So that is a little bit odd. So let's go down here to another frequency. Hang on. So it is locked. Hang on a second. Okay, so let's go down to, let me say 7 megahertz. AM, and wow, we not sure if you can read it. So output power it's 223 watt. So that is definitely too much. I mean, we know as lower the frequency is, the fan is coming in, so that is a good sign. Anyways, as lower the frequency is, as higher the amplification, or a higher amplification is possible due to the lower frequency. So that might be the right way to explain it. And when we go up here to the 15 meter band, and I do the same, it is only in brackets 150 watt, so that is normal. And when I go up to, let me say 10 meter, and let me switch it to AM as well, and there it is down to 145. But in any case, and I don't know if you can see it here, so for a second or less a second, you see that it does not directly jump up to full power. So for a short moment it seems to stay down at whatever it is. I can't verify it for the moment in time, but I recognize that the power meter is coming up with a little delay. Don't know if you can see it, and it is not always, it is sometimes. Okay, so that leads me to the question, is there maybe something wrong with ALC? So let me simply reduce output power. So it is 100 watt right now. This radio has 3 settings, 10 watt, 50 watt and 100 watt, and that's it. So let's go to 10 watt output power, indicated by the L down here on the display. And yeah, now the radio should be showing less than 10 watt, because we are here on AM, so maybe 3 watt or whatever, but lower than 10 with dead key. So let's see what we can find. I'm not sure if you see it. So 100 and dead key 105. Have you seen that? So we had really a jump from 5 watt to 100. But it seems that it tries to adjust to 5 watt, but then it jumps up. We have this delay, but then it sticks. Boom. Yeah, so it looks like there is something wrong with ALC. So let me switch to FM, and here we should have 10. When 10 watt is dialed in, and it is 10 watt. 107. So, but it is the same game. So the radio tries sometimes to adjust it to 10, and then suddenly it jumps up to full power. So that indicates that maybe something is wrong with our ALC circuit. So what we need to do is, okay, we know we have the problem here with our key jack for CW, but that is solved with the, let me call it, blind connector or blind jack, whatever. So no problem in the moment. When I pull it, we have back our tone, okay, but that doesn't hurt us right now. What we need to do is we have to crack it open, and we need to check the ALC circuit and see if everything is okay with ALC or if something is wrong. We will find it out. Okay, so we are in, and here we have a nice view on our board. So that is TX-RX unit, and well, very interesting with the TS50 is always this little boards here all over. So these boards are hybrids, and these hybrids are known for making trouble, because after a period of time they start and doing funny things, so that the connections are bad or whatever. And the problem is we do not get any replacement. So if there is really something wrong, that what we can do is very limited. I mean, okay, so for instance, if we go a little closer down here, this here is the ALC amplifier. And yeah, this amplifier finally has to handle the wanted power. So it is a kind, or no, it's not a kind, it is a comparator. And from the microprocessor unit, we get an information to this comparator, and it will be then set to 10, 50 or 100 watt output power, and then we have a line from our detector right at the output, so somewhere very close to the antenna jack, and then we get our forward signal information. And if the forward signal is too low, then the ALC will give the information, hey, increase the power. And if something is wrong here or with the sensor at the antenna, then it might be what we have seen, that the radio is always trying and pushing for full power, because maybe the information from the power sensor is missing, and that then means the radio tries to increase the power because the feedback from the sensor is not available here at the ALC amplifier. And that is what we need to investigate. So when I now switch back on the radio, and I have taken out the internal speaker, so hang on a second. Okay, so my external speaker is now connected to the radio, so we have audio, and yeah, for the moment in time it is very funny, because let me go here a little bit back so that you can see it. Radio is switched to, can you see it, AM. Yeah, you can see it, AM, and yeah, I do not get any output power, so the meter is simply telling nothing, absolutely nothing, dead. So, and that, you know, let's see if we just play here a little bit with this board, and let me see, that is maybe the better view. Yeah, have a look. That is exactly what I thought. That is exactly what I thought. So something is wrong here with our ALC board. So that is what we 23 watt is what we want to see. So that is what I set that key on AM 25. That's it. But it jumps up to full power. And yeah, the only thing I'm doing here is just simply wiggling here and pressing it a little bit. Now output power is gone again. Yeah, nothing. I can do whatever I want. And when I now go and yeah, power is back. Here we are. And so if we are really lucky, sorry, interrupted. So if we are really lucky, then we have only a cold solder joint. So what I gonna do right now, I gonna take here this board out and yeah, reflow the solder points at the ALC amplifier down here. And yeah, I just want to see if there is something additional what we may see here on it. So yeah, that will be our next step. I take it out and then I will be back. Right, here is our board, and to be honest, I'm not really happy what I see, because if we zoom in here a little bit, so these are the connectors here from our ALC amplifier board, which we have down here. And well, as far as I can see it, the solder points are all fine, so there is really nothing obvious. So they really look quite nice, and that means that maybe there is something directly here on this board. And the funny thing is that Kenwood is calling this board IC, so it is an integrated circle, and they do not explain in depth what they have on it. So there is rough information in the service manual, okay, but no detailed information. But that is not the most worse. So the most worse is that we could have something wrong here on the board. So maybe this little let me zoom in, this little pots which could be faulty, or there is a solder point, whatever, or it can also be here on the main PCB. So that is really the question. And as I already told you, this radio is known for problems on this little extra boards. More worse is this extra board here, so you can't do really anything on it if there is something wrong. So yeah, I'm really not happy. So we have the choice right now to simply reflow it and try it once again, or we take it completely out and check if we find maybe something on the board itself, but I don't know right now. Okay, first step first, so I go and reflow it completely. Then I put it back and let's check if we see any difference, and yeah, then we decide how we proceed. So okay, this is now completely reflowed, everything done, and yeah, let me put it back to double check what's going on. But well, beside that, I have just poked around a little bit and checked here the electrolytic capacitors, because we know that these capacitors are not the best. So maybe you've seen the video from Buddy from the radio shop, and here's the TS50 on the bench as well, and all the capacitors were leaking and destroyed the complete board. So we know that there is definitely a problem with these capacitors. Even we have here a very clean board, but yeah, I have poked around a little bit with this here, and let me see that I get here a contact, and come on. Yeah, so 7.5 ohm, which is definitely much too high. So this here is 8.6, and let's check this guy here for instance, and we have 38 ohm for this ESR, and I mean this here are 47 microfarad capacitors, and even if we only take this crappy list here, I mean this is not really telling the truth, but even then 47 microfarad with 16 volt should have maximum 1.6 ohm, and we have 7.8 and 8 point I don't know, and the other one I've tested is a 10 microfarad with 16 volt, which is allowed to have 8 ohm, and we measured approximately 40. So that is definitely an indication for that the capacitors are worn out. And yeah, recently I had a question in or under one video asking if I would directly swap all the capacitors, and I said no, normally not. If the radio is working, no, I wouldn't do it. But if a radio is known for having problems with capacitors, even when the radio is a couple of years old, let me say more than 10 years, I would check some of the capacitors like I have done it here, just to get a feeling what's going on. And we clearly see that the capacitors are kind of worn out, and therefore, yeah, in this case I definitely would swap all the capacitors here on the board, because we know that these capacitors are nearly almost dead, and we should really swap them before they start leaking, because leaking would be the next step what these capacitors would develop. So therefore, yeah, I would swap them, but anyways, that is now another story. So that was just of interest to get a feeling First of all, before we do anything else, we need to check if we are able to get this loose connection wherever it is out of the way, and yeah, that is hard enough. So let me put it back into the radio and let us check if we have a difference. Okay, so the board is back in, and I have already tried and see what's going on, and unfortunately it is more or less the same problem. So it does not make any difference with the refloat solder joint, so there is no difference at all. So what we can see, let me here go onto our power meter, it is still between full and nothing, and yeah, I know, or I see when I'm just yeah, let me do it this way. So when I just press down here the board, it will make a difference. So for instance, right now there is no output at all, right? So of course I'm pressing but nothing, and simply by pressing down the board here, I have back power. So you know, that is exactly what is known from this radio, and the problem is this is minimum. Let me see if we can see it a little better. Minimum, we have a 2-layer board, so you can see it here and there. So these are through connections, and the problem is maybe the fault is not here on this little extra board, so maybe it is simply on the main PCB, and maybe that here one from this through connections is not good. So that is a pain in the ass, so you know, nightmare. Okay, I mean, I don't know how much to put into this radio, as I know this radio is a nightmare, but yeah, let us try 1 or 2 times more. Just maybe we find a bad connection, but when it is here on a through connection or whatever, then yeah, we are really out of the game. So that is for sure, and that is really a shame, because you know, this is a nice radio, really it is. But well, okay, so I take it apart once again, and yeah, let's see if there is something else we can do. Well, and maybe we are a little bit lucky. So what you can see here is a view through the microscope, and this is one solder point, and you see we have yeah, let me minimum call it not so good connection, and that maybe is one reason. Hopefully, we really don't know, but this, you know, is yeah, a little step into the right direction, and so we want to reflow this solder joint down here, and maybe we are lucky. So let me show you where it really is on the board. So I simply here go back so that you have really the view. So yeah, you watched here through the lens, and the joint which is suspect is this one here, right? So this is really looking bad, and when I flip it over, yeah, no, I have to show it this way. And when we were testing, I needed to press here in this area very hard on the board, and then I got back the power, or you know, I saw in any way, in any kind, I saw a reaction, and the bad solder joint is here from this connector here. So it is very close here to the point where I needed to press on to get the radio back. So therefore that will be the next. I will reflow now, and a little bit, just a little bit, you can see it here as well. So let me see how far I can zoom in. Now it is going out of focus, but maybe you can already see just a little bit what you have seen through the microscope. So that is the suspect joint, and yeah, so we reflow the complete connector, and we give it another try. Okay, all done. So let's put it back into the radio, and let's give it another try. So maybe we are lucky. Okay, so all work done, and yeah, I also find here some bad solder joints which are here, these little boards, and so yeah, there are some. So that is not very nice, but yeah, if we are lucky, we really have now found all the bad joints, and let's see, we put it back into the radio, and then we know more. Okay, so board is now back here in our circuit, and yeah, as I already said, I have reflowed the complete boards here, and there we had really some yeah, solder point cracks, and so that was really responsible for the interruptions we had. So that is done. Then we had here at this relay we had cold solder joints, and so this is fixed as well, and some of these coils had bad solder points as well. So that all is done, but what we can see, I get full output power, or even too much, because radio is adjusted to 50 watt, and that means that yeah, something is still wrong, and that leads us back to our ALC unit, and our ALC unit is down here, and very important for the function of our ALC unit is that we have all the respective voltages available, and we need plus 8 volt, which should be available down here at our pin. It must be pin 2. So when I go down here and try to probe this point, then I'm down here yet now at the point, and yeah, we have 7.9, so close enough. So that should be 8 volt, just fine, no problems. Then we have a negative voltage, which is also supplied to the ALC unit, and that should be at this test point. And yeah, have a look to what we have. So this should be a constant -6 volt. So that is -6 volt line, and what you see here is a jumping voltage, and that is the reason why the radio is now always putting full power out. I mean, we have fixed the problem that we had sometimes no output power, so that was due to the cracked solder points. But this here is definitely something wrong in the -6 volt supply. So what we need to investigate is our -6 volt power supply. Yeah, therefore we need to have a look here into our schematic, and this here is our ALC unit, and yeah, what you can see here, here's our supply plus 8 volt, and we have checked this, and it is just fine. And here we have our -6.2, which should be at this point, and that is what we checked, and we saw this jumping negative voltage, which is not okay. And when we follow the trace here, we find here on the left hand side our voltage, or our negative power supply, which is this here. It consists of a stable multivibrator, and we have here a rectifier, we have here a Zener diode, and then we have here our -6.2 volt available at our output. At this coil here we should have our -6.2 volt. And yeah, when I go down, and I know that the little coil is here behind the ribbon cable, and when I probe exactly, oops, we can't see it. Yeah, so you see we have exactly this problem here, and it is jumping, or we have nothing. So right now, so there is no output at all. So let me go back to this point, and you see it is jumping. Yeah, so really crazy. And if you remember, when I've taken out the board, I just checked some of the capacities, the electrolytic capacities, and we found that we had some SMD capacitors, which are here, down here, are had a very bad ESR. And have a look here into the schematic, and what you find here are exactly this you know, capacitor. So our 47 microfarad 16 volt capacitors here and here, and that are the capacitors which had a very bad ESR, and I could bet that yeah, due to the faulty capacitors, we have this jumping output voltage, and if we do not have this minus 6.2 volt at our ALC circuit, then you know it is not possible that the ALC circuit works correctly, and that is the reason why the radio is always firing full power out. And therefore what we now gonna do, I take out the board, and I go and replace this SMD capacitors, and then let's see if after that we have back our negative 6 volt. Okay? Yeah, and here our suspect capacitors, and we already had measured those with a very bad ESR. So we gonna change it, and then we will see how it works afterwards. And once again, especially this capacitor here is the output out of our multivibrator, and this capacitor is feeding the rectifier here, and you may you may understand if this capacitor is not able to deliver, then we will have such bad or odd behavior. So yeah, let's go and change. Okay, so now I have replaced these 4 capacitors, and yeah, here we have the faulty one. So now let's put it back and see if it makes any difference. Okay, so now the PCB is back with the new capacitors, and you see that you know, it is much more stable, but there is still an instability. It is not as it should be, so we should have minus 6.2 volt, and that is not really present. So you see it's still jumping a little bit, also it is much better. And when I now go and press my PTT, all right, so you suddenly see collapsing the voltage. So let me switch on the light. So I'm pressing, you know, the PTT, and you see the minus 6 volt is collapsing, and that is not as it should be. So it needs to stay. So maybe that the Zener diode which we have in this circuit is also dead. I don't know, so we need to check that. But before we do that, I have here now minus 6 volt from my power supply. Okay, and what I just want to check is if I inject my minus 6 volt from the power supply, I need to arrange it a little bit different. 1 second. So now you can see it much better. So I'm injecting minus 6 volt from my power supply, and now I have a stable minus 6 volt. And even when I press here my PTT, you see our voltage is completely stable, right? And if we now, so I leave it here as it is, our -6 volt. And when I now go and watch our power meter, so radio is set to 10 watt output, and you see, very nice. Now I set it to 50 watt output, and wonderful. And 100 volt, wonderful. Back to 10 volt, not volt, sorry, watt of course. And we have our 10 watt. So that means, yeah, the only thing we have now to fix is the power supply, our -6 volt power supply, because that is the problem we have. As soon I take my external power supply away, and you can see it, can you see it? Maybe if I put this a little bit away, you may see. So it's not able, now we have focus. Yeah, so that is my 6.2 volt, and that is what we can read here now at our voltmeter, and I'm simply injecting it into the -6.2 volt pass. And that means we see a nice improvement after we have changed you know, the capacitors, but it is collapsing as soon I'm pressing the PTT. So therefore we need to go back to our -6 volt power supply, and we need to check it out and see what the problem is. So maybe that the Zener diode is dead as well and is not able to stabilize our -6.2 volt. So that will be next. Okay, so board is out, and we are here down at our negative power supply, and well, here is our Zener diode, and well, what we can see, we have the same issue. So you see that it is not stable, and yeah, so that is a little bit odd. Also, it seems that the Zener diode tries to stabilize, but something is not going and working as it should. So therefore I've connected here my scope, and yeah, when we let me see that we have not too much reflections. I hope that will work. So now when I go and check the voltage out of our multi-vibrator, so then we see, and that is right. So what we see is yeah, the switching. It's another kind of switching power supply, but what really looks a little bit odd is this here. I don't know if you see that it is flickering here, and therefore, I mean, we have a nice 18 kilohertz square wave where we can simply form our DC voltage from. But yeah, something is a little bit odd here, and yeah, let me see if we can find it. And so that is really something unusual, because what we can see is that there is a package missing in between, and I'm not sure, so let me go at the output of one of the rectifier diodes, and that is here. Okay, so once again, and you see there we have our jumping output, and it looks a little bit to me that maybe there is a diode not working, because there is missing a half wave. I'm not entirely sure, but it looks like. So yeah, I need to check the rectifier, I guess. Okay, so far I have replaced the Zener diode down here, as we have seen that the output voltage was not stable, and secondly, we had a very odd behavior when we were probing with the scope. So therefore I've taken the old Zener diode out and replaced it with a new one, and now the circuit is connected to the power supply, and well, I'm now interested in the voltage which we have, of course, at our Zener diode, and have a look. So the voltage is absolutely stable. So when you see it flickering, that is because my hand is not that stable, but you know, the voltage down here is really stable. So that was obviously the problem. The Zener diode was dead, so not able to stabilize the voltage correctly, and yeah, maybe together with the old and worn out capacitors which we had replaced. So this SMD capacitors, we have seen that they had a high ESR, so maybe that had an impact. I'm not entirely sure, but anyways, now it looks good. And when we now go and watch our scope, and I go back into the circuit, you see now our signal is really clean. So we do not have this yeah, second line here, and what, so that's me, that is me. And when I go now here into this view, you see we have not this missing packages anymore. So this is what we wanted to have, and yeah, that seems to be the proof that yeah, it was really a bad Zener diode, and I have tested the Zener diode at our diode tester, and yeah, I can tell you it was not visible at the diode tester. So it looks like that it is a good and working diode, but yeah, especially my diode tester is not able to test the Zener voltage, and that is what is the problem. So therefore my tester said everything nice, but it wasn't. So okay, it seems that everything is fine right now, and yeah, let me bring the PCB back into the radio, And yeah, let us check if now the output power is as we have it pre-adjusted in our menu. So, well, we will see. Alright, and PCB is back, and I'm down at our test point, and yeah, what you can see, we have minus 6.3 volt available at the test point and no flickering. So the voltage is completely stable without any problems. And now I just want to press PTT, and last time we saw that the voltage was collapsing. And now we try the same, and what we can see is that the voltage is stable. So the voltage is not collapsing, and that is what we want to see. So that is obviously now a good working power supply for the negative voltage. And now we are of course interested in our power, and radio is set to FM, so that I have the carrier to I can check it finally. And radio is set to 10 watt output power, and 11.7, close enough. So let's switch it to 50 and 52, also close enough, very nice. And 100 watt, let's see what we have there, 104. Yeah, and what you can definitely see here is that yeah, this negative voltage had really an impact on the whole circuit. So that was the reason why the ALC was freaking out, and now with our stable negative power supply, everything is back fine. Yeah, I would call this repair not that simple. So it was a little bit tricky because we had some mixing up problems. So we definitely had here our broken connections, solder connections, which lead to yeah, switching completely off our amplification, because the signal were not able to pass through, and we had some bad solder connections, I don't know, here at our relay, and here at some of this coils. So yeah, one fault was really interacting with the other fault, and yeah, therefore it was a little bit tricky. But anyways, all bad connection seems to be good right now, without any problems. Our power supply is working perfectly again, so that radio is completely fixed. So we have changed our bad capacitors as well. So therefore we can consider this radio as fully working, and yeah, therefore radio can go back to the owner. And I'm at the end of this video, and as always, if you like this video, please give me a big thumb up, and catch you next time. Bye!